NASA gave a basic counsel. Pluto is not what you think. What is NASA recommending here? Are they implying the latest disclosures from the New Horizons spacecraft, which show that odd things are going on Pluto's surface? One of the perilous pictures, truth be told, shows an article that appears by all accounts to drift across the external layer of Pluto. This raises disturbing questions concerning whether some kind of advanced life exists on this distant world, or are we making do with a curious geological idiosyncrasy? Pluto may be close to nothing, but the accounts it needs to tell are enormous and loaded with surprises. When Pluto's planetary status was revoked in 2006, specialists were unaware of the data from the New Horizons mission, which only reached Pluto after 9 years. Since then, we have learned that there is more to this little guy than was expected. How did space experts come to deny this planet, which we have all somehow grown up with? The status of a real planet had been established after the discovery of various other small planets in the Kuiper Belt. They concluded that we truly needed a limit for what constitutes a planet and what qualifies as a dwarf planet or trans-Neptunian object. Pluto scores points for its size and round shape, but it shares its orbit with a few other items, making it not seen as a perfect candidate. This was unequivocally the reason why Pluto was not generally associated with the rundown of major planets in the planetary bunch. Many people on Earth think this is a shame, and the decision by space specialists caused dissatisfaction among the public. The fact that this little makeshift planet has so many fans led to letters of complaint to NASA from notable scientists who supported Pluto's classification as a planet. Even state-run governments received letters from perturbed inhabitants requesting that Pluto be classified as a planet again. This planet has been with us since the 1930s and was an important part of a movement of 9 planets. It was as if to reinforce this in 2015 when New Horizons sent us the first genuine picture. The spacecraft showed us Pluto's delightful face. Assuming that you've seen the planet in school textbooks before, those were imaginative depictions, not real pictures. Pluto denied even the Hubble telescope a clear perspective on its surface, but New Horizons was allowed to photograph this little one as it truly is. Bright, friendly, undeniably rich, and with a heart. Since then, the planet on the external edge of the neighborhood planetary bunch has won over many more fans, and perhaps space specialists will change their points of view one day, allowing us to get Pluto back. The first genuine pictures of Pluto blew everybody's mind. It was an otherworldly moment when the essential data from the New Horizons mission arrived at headquarters in 2015. Everyone present knew that they were about to see a planet for the first time that everybody was somehow acquainted with but had never seen up close. The computers on Earth pieced together this enchanting picture from huge amounts of individual pieces and pixels. What the mission uncovered about Pluto was a revelation that completely turned our comprehension of this faraway planet on its head. Pluto is considerably more changed, organized, and altogether more alive than planetary researchers had previously acknowledged. Moreover, the little planet appeared to be covered in seen features and maybe even atmospheric quirks, which nobody had expected. With each new piece that New Horizons delivered, the cloudy, confusing world in the darkness of the Kuiper Belt transformed into a significant object that showed such an excess of life that it took analysts' breath away. More and more amazing geographical wonders opened up before researchers. Rather than the ordinary, bone-chilling, cratered no-man's land, Pluto ended up being a unique spot with heavenly lumps of ice, deep crevasses, and smooth, frigid surfaces. It required years for the countless measurements, data, photos, and revelations to make the long journey from Pluto to Earth. Since 2015, we have been amazed more than once with new, spellbinding perspectives about Pluto. Who is that walking on Pluto's surface? It's dazzling. This moving picture circulated in the media in 2016. But what might you see here? It looks like an individual is strolling across a strange honeycomb-shaped snow float. You can actually see ice scenes here, but unlike Earth, these frozen surfaces are not made of water but of nitrogen and methane. Researchers identified the surprising item as a grimy lump of ice, which gives the impression of drifting over the surface of the ice-covered plain. The gigantic block of ice is likely made of solid nitrogen. These bizarre-looking landforms revealed something extremely special to specialists. They now believe there is a nitrogen supply a few kilometers beneath Pluto's surface, where the solid blocks undergo geological activity. The interior of the planet pushes these blocks upwards, creating the honeycombs and formations like the seemingly wandering mountains. This points to a warm core of the planet, and this finding could have broad repercussions for how we may interpret Pluto. It is certainly more dynamic than previously acknowledged. Land development from heat, alongside changes in surface features, exhibits a kind of aliveness that shows we have misjudged Pluto. This little guy shows not just some consideration but also fire within, suggesting that there are pockets of liquid inside Pluto that look like oceans or magma. William McKinnon, the topography lead of the New Horizons mission, even compared the interior presence of the minor planet to an area the size of Hudson Bay in Canada. Virtual experiences showed that this remarkable scene has been created over millennia and is still extremely powerful today. Can you see the specific X on the right underneath the cold mass? This formation was likely made by sublimation, an interaction in which a substance changes directly from a solid to a gaseous state, with the liquid stage evaporating. These cycles occur due to the extreme temperatures on Pluto, leading to confusing topographical cycles and environmental eccentricities in what was once considered a dead world. Christmas in the snow on Pluto? Does that sound crazy to you? Well, it's a reality. Pluto genuinely is a conundrum. The New Horizons mission uncovered charming pieces of the climate and occasional changes on this planet. Pluto, which circles in the cool, faraway realms of the Kuiper Belt, experiences enormous seasonal variations due to its surprising orbit and tilt. The New Horizons spacecraft found that Pluto's atmosphere, a thin layer of nitrogen, methane, and carbon monoxide, changes dramatically depending on how close or far Pluto is from the Sun. These changes affect not only the climate but also the surface conditions of the dwarf planet. One especially amazing aspect of the environmental components is snow on Pluto, which comprises mainly frozen nitrogen and methane, unlike Earth where snow forms only from water. The extremely low temperatures on Pluto cause the more volatile gases, nitrogen and methane, to accumulate and fall as intriguing snow. All these interactions shape and invigorate Pluto's surface by covering the landscape with new deposits. The disturbances in turn drive other topographical movements, such as icy advancement and perhaps even cryovolcanic cycles. The New Horizons research also showed that these seasonal cycles are closely associated with atmospheric density. When Pluto is nearest to the Sun, the slender light is enough to heat up the dwarf planet's air, making it expand slightly and rise. When Pluto moves away from the Sun, the air freezes and sinks back to the surface. This peculiarity leads to a striking oddity. When Pluto's atmosphere consolidates, it could literally snow, with snow made of nitrogen and methane. The variations in surface brightness and the distribution of cold deposits further suggest that practically all surface features and landscapes on Pluto are connected with these environmental cycles. Since Pluto's mountains are not made of rock but of ice, which is very flexible in this world, the whole surface moves far more than that of our Earth. For example, what does Pluto's heart comprise? Who could have imagined that Pluto's heart isn't just a delightful warm imprint in addition to its famous appearance? This region is also one of the most astonishing on the planet, previously called Sputnik Planum. The area is named after the first artificial satellite, Sputnik 1, which the Soviet Union sent into space in 1957. This enormous heart-shaped ice surface stretches over an area of around 1,000 kilometers and is primarily made of nitrogen ice with hints of frozen methane and carbon monoxide. The brilliant, almost ideal surface of Sputnik Planum forms a striking contrast to the darker, more complex regions around it. Topographically, Sputnik Planum is a gigantic impact structure that was likely later adjusted by volcanic cycles. Similar to regular volcanic movement on Earth, where magma rises from the planet's interior, cryovolcanism on Pluto involves cold materials rising from the dwarf planet's interior to the surface. The heat sources in Pluto's depths cause nitrogen and other volatile substances to heat up and push upwards, where they freeze and form novel developments. Sputnik Planum is undeniably flat, which drives researchers to infer that the cold surface is routinely invigorated by internal cycles. It's likely convection processes inside the ice sheet shape these landscapes. Researchers speculate that there may be a span of liquid water underneath the smooth ice sheet of Sputnik Planum, which is kept liquid by the heat inside Pluto. They question whether kinds of life can exist in the subglacial ocean, but it's not completely inconceivable. What role does Charon play? What hardly anyone knew is that before the New Horizons mission, Pluto had its own moon, and not just one. Charon is Pluto's largest moon and was found in 1978 by the American astronomer James Christie. Charon is quite large in comparison with Pluto, with a diameter of roughly half that of Pluto. This has led to a unique relationship between Pluto and Charon, where the two objects are tidally locked, implying that Pluto and Charon constantly show the same side to each other. Charon's surface is also incredibly different from Pluto's, featuring enormous canyons and massive impact craters. Researchers believe that Pluto and Charon have been trading materials in the form of comet-like objects. Pluto's complex relationship with Charon extends beyond mere proximity. The two bodies influence each other's geological and atmospheric conditions. The gravitational pull between Pluto and Charon is so strong that they effectively orbit a shared center of mass located outside of Pluto. This unique dynamic is known as a double dwarf planet system and highlights the distinct characteristics of both bodies. Studies suggest that Charon may also harbor some surprising features of its own. For instance, Charon's surface shows evidence of extensive geological activity, including large canyons and possible cryovolcanic features. This raises intriguing questions about its internal structure and whether it, too, may have pockets of liquid beneath its icy crust. The presence of such features indicates that Charon is not merely a passive satellite, but may have an active geology driven by its own internal heat. The color and composition of Charon are also noteworthy. Its surface exhibits a reddish hue in certain areas, thought to be caused by the presence of tholins, complex organic compounds formed by the interaction of sunlight with methane and other simple carbon-based molecules. This coloration sets it apart from the predominantly icy surface of Pluto and suggests a rich and varied geological history. Pluto and Charon's unique interaction extends to their atmospheres as well. When Pluto approaches the Sun, its thin atmosphere, primarily composed of nitrogen, expands. This expansion can influence the atmospheric conditions on Charon, possibly causing temporary variations in its own atmospheric dynamics. As Pluto moves farther away, its atmosphere contracts, which could lead to changes in the surface features of both bodies. Interestingly, the discovery of Pluto's other moons, Nix and Hydra, adds further complexity to this celestial dance. These smaller moons are irregularly shaped and appear to be remnants from the early solar system. Their orbits and characteristics suggest that they may have formed from debris created during a collision or other significant event in the distant past. Understanding their formation and evolution could provide insights into the processes that shaped the outer solar system. Recent modeling of the Kuiper belt suggests that Pluto and its companions may have been influenced by gravitational interactions with larger bodies in the early solar system. This could have led to the chaotic orbits observed today, making the study of these celestial objects even more fascinating. Future missions to Pluto and Charon could unveil more about their geological histories, atmospheres, and potential for hosting life. The exploration of such distant worlds is crucial for expanding our understanding of the solar system's evolution and the conditions that might support life. Additionally, as we refine our observational techniques, we may discover even smaller moons orbiting Pluto, further complicating its already intricate system. Each new discovery enriches our knowledge and emphasizes the need for continued exploration of these distant realms. Ultimately, Pluto and Charon represent a captivating chapter in the ongoing story of our solar system, challenging our perceptions and sparking our curiosity about the universe beyond our home planet. The exploration of Pluto and Charon opens up intriguing possibilities regarding the potential for life in extreme environments. Researchers are particularly interested in the presence of cryovolcanism, which involves the eruption of icy materials rather than molten rock. This phenomenon could create subsurface oceans, akin to those suspected on moons like Europa and Enceladus, raising questions about whether similar processes might occur on Pluto and its moons. Another fascinating aspect of Pluto's environment is its seasonal changes, which are influenced by its axial tilt and elliptical orbit. As Pluto journeys around the Sun, its seasons can last for decades, leading to dramatic shifts in surface conditions. This variability may impact the distribution of gases and surface ices, further contributing to its dynamic landscape. Moreover, The study of Pluto's atmosphere provides valuable insights into the behavior of gases at extreme distances from the Sun. Understanding how nitrogen, methane, and carbon monoxide interact under such low temperatures can inform models of other celestial bodies with similar conditions. The ongoing analysis of data from the New Horizons mission continues to unveil secrets about this distant world, fueling excitement for future explorations that might reveal even more about the nature of our solar system's outer reaches. Each discovery underscores the complexity and richness of the universe beyond what we can observe from Earth.